The final lesson in this chapter has to do with solving quadratic inequalities. Now, I know for some of you that sounds kind of confusing, but quadratic means an equation with x squared to the second power. And inequalities are really just all of the symbols that are not equal, the greater than, the less than, the greater than or equal to. Okay, those are inequalities. So when you have x squared with one of these signs, remember, we cannot square root. We cannot square root x squared, okay, with the inequalities. So I'm going to show you some techniques here of things that you can do. And number line was usually one of them. Okay, so let's write down the steps here. Okay, so the first thing we're going to do is move all terms to one side. Move all terms to one side. Doesn't matter. Pick a side. Okay, so that it's less than 0, or greater than 0, or less than or equal to 0. Okay, see how this works? Everything is on one side. Step 2, there's the fun part. You're going to factor that quadratic. Going to factor. Step 3, you find the critical values. And by critical values, that means the zeros. Okay, something happens critically when it touches the x-axis. It goes from above the x-axis to below. And that means it goes from positive to negative. So if we want less than 0 or greater than 0, that's where it's going to happen. It's going to happen on the x-axis. Number 4, we're going to draw just a quick graph. A quick graph to show us what's going on. Okay, you want to make sure that you include your zeros, and then you want to include or show whether it's going up or down. Okay, and that's by how quick. It doesn't have to be point by point, a perfect parabola. It's just a quick graph. And 5, you're going to state where is that parabola. Where is that parabola, depending on the question, greater than 0, less than 0, greater than or equal to 0. So depending on the original problem, you're going to say where the parabola is, what you wanted. Okay, here's some examples. Solve this quadratic inequality. Step 1, move all the terms. I'm going to move them to the left side, because factoring for me is a lot easier when it's like that. So 2x squared minus x minus 10 is less than 0. Okay, step 1 completed. Step 2, factor. Okay, we're going to factor here. How do you make a 2x squared? Well, it's got to be 2x times x. That's the only way. And how do you make a 10? 5 and a 2. So if I put the 5 here, that's 5x. If I put 2 right here, so my outers are 4x, my inners are 5x. That would work if this was negative and this was positive. So however you got to get this thing factored, you could take more steps and make it in a table and stuff, but you got to get it factored. Okay, step 3, find the critical values and draw a quick graph. So on this nice fast graph, one of the critical values is negative 2. One of the critical values is 5 halves. 5 halves. And this parabola is opening up. Okay, so here's the parabola opening up. Just a quick graph, parabola opening up. Okay, now, what's the question here? This is parabola, and I want to know, where's the parabola less than 0? Where's the parabola negative? Where is it down below 0? It does not say equal, so I cannot use these points right here. The parabola is less than 0, all this part of the parabola. This is all less. These arms are above 0, so that would be the answer. So since those are open bubbles from the left hand sign, I'm going to say negative 2 parentheses up to 5 halves. You could also use the inequality notation, say negative 2 less than x less than 5/2. Okay, and let's just remind everyone what those are called. When it's parentheses and brackets, that's called interval notation. And this is inequality notation. If it says to use a specific notation, make sure you do. Otherwise, I will accept anything that's correct. Okay, next one. Step 1, make it equal to 0. It already is equal to 0. So all I'm going to have to do is factor. Let's take out an x. That's x plus 8 is less than or equal to 0. So let's draw this quick graph. This is an x. Right there, I would write x equal to 0. So that's one of the critical values. And then this, x plus 8 equals 0, you get negative 8. Okay, if that was a number, then you wouldn't say number equals 0. It's only when it's an x. This parabola is opening up. So let's touch that x-intercept. Let's touch that x-intercept. And now it's time to answer the questions. This says less than or equal. So here you want to include these points, equal and less. Okay, this question says, where is the parabola less than 0? All of this is less than 0. So from brackets, negative 8 to 0. Okay, what we've done in the past, another technique for solving these would be to factor and draw a number line and go from negative 8 to 0. You're going to put closed points, and then you'd have to test the sections by taking numbers from each section and calculating. So instead of doing a numeric calculation on a number line that's one dimension, you could go two-dimensional and look at the visual, which I think is going to be a little easier. Okay, let's do some more. This next example up here on the top has a negative. So if we were to move everything else to the left-hand side, okay, it could totally be done. Negative x squared minus 7x minus 12 is less than or equal to 0. So you can do that, but what you have to do first is factor out the negative. Factor out the negative and write the new quadratic. Positive, positive, positive. There's a lot of people not writing this step, and then they try to factor, I guess, with this equation in their head, and it's just not working. So we have a negative out in front, but that's not an x, it's just a negative sign. Now we're going to go ahead and factor. The only way to make x squared is to do x times x. 12 is a little more interesting. It could be 12 and 1, but those don't add to 7. It could be 2 and 6. It could be 3 and 4, plus 3 plus 4. So if I look at a quick graph, I've got x-intercepts at negative 3, negative 4. Negative 3, negative 4, and this is a parabola that's opening down. So I want to make sure that I have a parabola that's opening down with those x-intercepts. Okay. It says here that they want less than or equal to 0, so that's going to be equal, and that's going to be equal. And where is this parabola less than 0? Here, this arm and this arm. So we have two pieces that are less than 0. So I'm going to say from parentheses, negative infinity up to negative 4 with brackets, union, brackets, negative 3 to infinity. All right, some people are wondering, why didn't I just move everything to the other side? Okay, or at this point, what if I multiplied everybody by negative, both sides? Then that would have been positive, positive, positive. But then you'd have to flip the sign. And let me just show you what would have happened. As long as you remember to flip that sign when you multiply or divide by negative, I've got x plus 3, x plus 4 greater than or equal to 0. So the x-intercepts are still negative 4 and negative 3, but this parabola is opening up. Is that going to change things? Okay, now what does this problem say? It says, where is the parabola greater than or equal to 0? So this parabola is greater than 0 here at this arm and this arm. So the answer is going to be the same no matter how you approach this, as long as you do all your algebra legally. All right, this next example here, we're going to have to do some distributing first. So let's go ahead and distribute x squared minus 7x. Some people said, well, isn't it already factored? Except there's no such thing as the 8 product property. And what I mean by that is if you have something times something equals 8, what is this parenthesis? I don't know. I mean, I guess this could be 2 and a 4, or that's a 4 and that's a 2, or that's the 1 and that's an 8. Okay, I don't know. They could even be fractions. But if I have something times something equal to 0, I know without a doubt that this one is definitely 0, or this one is definitely 0. Okay, but one of them must be a 0. Just because you have an 8 doesn't mean one of them must be a 0. This right here is called the 0 product property. And the 0 product property is what we're using when we're solving and factoring. So we cannot leave that 8. We're going to have to subtract the 8 to the other side and say greater than 0. Okay? Now when you have a trinomial, you're going to have to factor with two quantities. X squared is x and x. Now how are we going to make an 8? I'm noticing a 7 there. So it's probably not 2 and 4. It's probably 8 and 1. But how do you make a negative 8? Well, one of these has to be negative, and it's going to be the 8, because negative 8 plus 1 makes a negative 7. Okay, time for our parabola. The x-intercepts are negative 1, positive 8. This is a parabola opening up. So let's just draw a quick graph of a parabola opening up, and now we're going to shade the answer. Okay, just like our number lines need shading, I need to see the parabola darkened up. Where is it greater than 0? Okay, not equaling 0. Which part of this parabola is greater? This part and this part. From negative infinity to negative 1, parentheses, union, 8 to infinity. Okay. All right, we got one more here. Two more. This one's more the same, though. We're going to distribute the 2. 4x squared minus 6x. I'm going to add the 9, greater than or equal to 0. Okay, let's go ahead and factor this. Maybe let's try 2x and 2x. And then I'll try 3 and 3. Okay, does that work? Outers is 6x and 6x. Oh, that makes 12x. Even if they're negative, that's not working. Maybe this is a 9, maybe this is a 1. So the outers are 2x and 18. 2 and 18? Well, that doesn't make a 6. Let's try 4 times 1. So 4x and 9x. Well, that makes 5x. I'm having trouble. Somebody needs to help me. Trouble. Hey, I know what I could do. Because I'm kind of tired, and I don't know how much time I should spend on my test trying to factor. Here's a hint. Here's a hint for people that are wasting too much time on the test. Use the discriminant. What does the discriminant tell us? How many x-intercepts something has. Let's do a little test here. B squared minus 4ac. So b squared is going to be 36 minus 4 times a 4 times a 9. Well, 36 minus 4. 9 times 4 is 36. Oh, this is coming out negative. Oh my goodness, what's happening here? Okay, now we have to draw a graph. You still have to draw the graph. But this tells us no x intercepts. That is not the answer. That just helps us draw the graph. Okay, this is getting fun. So I need to draw a graph with no x-intercepts. Look at this parabola. The parabola is opening up with no x-intercepts. Okay, do you know where I'm going to put your graph? Like this. Okay, must still draw the graph. Okay, now we have to answer the question. No x-intercepts is not the answer to the question. The question said, where is the parabola greater than 0? And I want you to look at this picture and tell me, where is it greater than 0? Everywhere. This answer is all reals. Now don't start with that always. Just because the discriminant's negative doesn't mean that that's always the answer. That's just what this picture was showing us. Okay, we'll do a couple of those in just a second. Let's take a look at this one here and make sure that we're still good with domain. Okay, domain under a radical, that stuff under there has to be greater than or equal to 0. Negative 5x squared plus 7x is greater than or equal to 0. Oh, this looks like a quadratic inequality. Let's go ahead and factor out negative x. That's 5x minus 7, greater than or equal to 0. Make sure you write the entire equation. So the x-intercepts are 0 and 7/5. This is a parabola opening which way? Parabola opening down. Okay, there's a nice picture. And I'm going to use that picture to say my answer. Okay, where is the parabola greater than 0? Greater than or equal? Closed bubbles. And here's the parabola that's up from brackets 0 to 7/5. Okay, I want to talk more about this weird one here. And to do that, I've got this cute little chart here for us. So maybe I'll zoom out just a little bit. So here's a quadratic equation. And I want to calculate the discriminant. The discriminant is b squared minus 4ac. Okay, so b squared is 25 minus 4 times 2 times 9. 8 times 9, oh, that's definitely going to be negative. Okay, so it's going to be negative. Negative, so no x-intercepts. Okay, this example right here is the same. Okay, so we don't got to do it again. We can just say no x-intercepts because the discriminant is negative. Who cares? All right, here's a new problem. B squared, 16 minus 4ac. 16 minus 16 is 0. What does that mean? Therefore, one solution, or one x-intercept. Okay, here's a new problem. B squared minus 4ac. Negative times negative cancels. 16, that negative is going to stay. 8 times 11 is 88. Okay, the answer is negative. So no x-intercepts. And that's the same problem. So the answer is negative with no x-intercepts. Okay, why am I doing the same problem multiple times? You'll see in just a second. Now we have to draw a quick sketch of the graph. Okay, so there's no x-intercepts. No x-intercepts. Let's get some graphs going here. Okay. No x-intercepts. You're not allowed to touch the x-axis, and your parabola is opening up. Looks like this. This is the same one. No x-intercepts, parabola opening up. One x-intercept, parabola opening up. So that means it's going to be touching one time. One touch. This is no x-intercepts, parabola opening down. Draw your parabola down here. Same one. Draw your parabola down. No x-intercepts. Okay, now I'm going to give you a variety of problems, and you're going to look at these cute little pictures to tell me what the answers are. Okay, so if the problem had this equation that's up top there, if it had 2x squared plus 5x plus 9, and it said greater than 0, Where's the parabola greater than 0? Everywhere. You would say all reals. Now, what if it was the same problem, 2x squared plus 5x plus 9, but it said less than or equal to 0? Where's this parabola less than 0? Nowhere? Nowhere? Then you would say no solution. Okay, you can't say no solution with the discriminant. You got to look at that cute picture. What if this parabola, 4x squared minus 4x plus 1, said greater than or equal to 0? Where is he greater or equal to 0? Everywhere. That answer would be all reals. What if this parabola, negative 3x squared plus 4x minus 11, wanted to be greater than 0? Where is it greater? Nowhere. And what if this parabola right here wanted to be less than 0? Where is it less? Everywhere. Okay, you guys are coming into class, so I have to stop.